Good evening, everyone, and welcome to GordonStateWeather.com, GordonStateWeather.blogspot.com, Twitter, Facebook, and YouTube. I am meteorologist Robert Smith, and we're doing something brand new here. We're going to try this out. We're going to call it Weather Briefly, and it's an instructional video forecast discussion and look into Meteorology 101. Tonight's first episode, this Thursday evening, July 22nd, 2021. We're going to look at the water vapor channel of satellites that orbit and maintain or monitor the weather, actually, across the globe. And we're going to focus in on a couple of things and why meteorologists look at the water vapor channel and exactly what it is and what could it provide us. You know, in meteorology, we often look at mesoscale features in low levels, mid levels, and upper levels of the atmosphere, both on water vapor channel, which is the gas that produces the horizontal lifting and vertical lifting in the atmosphere. But the water vapor channel, unlike cumulus buildup or visible satellite imagery or infrared satellite imagery, can tell forecasters exactly many things. So we're going to start this Weather Briefly discussion tonight with the absolute water vapor channel. As a meteorologist, and as many meteorologists do, we like to look at a lot of features that satellites can provide us. And the new satellites, the GOES 16 and 17, are providing us with a lot more information than we've had since TIROS began back in the late 1960s. Tonight we're going to focus on the simple water vapor RGB, and basically the RGB helps discriminate the distribution of atmospheric water vapor. It allows the forecaster to distinguish where moisture return is occurring in the absence of clouds, and also it features traditional identified water vapor imagery such as conveyor belts, jet streams, gravity waves, which are very apparent. And tonight we have a great example of that to show you. This recipe is especially useful for color-sensitive individuals because of the contrast of colors between different levels. And we're going to take a look at this guide on the left here. As we look into the simple water vapor channel here, the blues are going to represent the low and mid-level moisture, okay? The greens are going to be the upper level moisture, but dry. It's dry below. Moisture at all levels in the lighter blues here. The darker blues are obviously going to show low level water vapor. And then we compare that with the low level, the mid level, and the upper level water vapor channels. But this is a simple water vapor explanation here. Also, black here would be all the dry levels or cloud-free levels in the atmosphere of water vapor, devoid of water vapor. Then we have mid-level clouds here, okay, in the pinks, mid-level clouds and low-level moisture, dry above, here in the darker magenta pinks here. And of course, all the whites here would be convective initiation, which means thunderstorms are occurring in these areas and high thick clouds here. So now we're going to take a look at some interesting things happening tonight. This is the absolute or simple water vapor channel here. We've got the light blues and pinks here, okay, which is moisture at all levels but no clouds or very little clouds, okay, low level moisture here. Which we had this afternoon, and some of the pinks showing up here, the light pinks, mid-level cloud decks showing up this evening. All the areas in black are moisture derived or moisture empty, actually. There's no moisture. And of course, along the stalled out front, the whites here are convection here. We're seeing plenty of thunderstorm development here in all of these white pockets here. And of course, the monsoon, which is occurring over the desert southwest to help fight the fires. But unfortunately, it's not in an area here where the forest fires are raging, and the smoke and haze that has come from forest fires here in Canada and also in Oregon is the reason why we had such milky skies, such beautiful sunrises and discolored sunsets as well over the last day, but that's pushed off the coast. If we went back in time here to yesterday, we definitely see the monsoon season building. We see the old frontal boundary here across the south. What's interesting here is that during today we had a lot of high and mid-level clouds across the area. Some low clouds below 5,000 feet or so, maybe 10,000 feet. And then when we compare this to low-level water vapor, and first of all, I want to stop this here with the convection. This is the monsoon season going on right now across the desert southwest into the upper plains. But there is no relief here, as you can see, in the absolute or simple water vapor channel here from all this heat. What we do see throughout of this is this huge ridge complex here. That's allowing the monsoon season to roll around the top of it, and there's a lot of convection here, and we'll get into that in a moment, and of course along the stalled out frontal boundary. Now yesterday, everything seemed copacetic until the afternoon when that cold front came through, and if you look closely into New Jersey and New York, there's a lot of mid-level clouds and mid-level moisture around, and also some low-level moisture that was able to be vertically lifted into the atmosphere to produce those showers and thunderstorms across Pennsylvania and northeastern New Jersey, including the coast and into New York City. It's a very interesting diagram. When we get into the low-level water vapor, this one's going to show up now, and you can see the disbursement of the cloud cover on the low-level water vapor imagery. You can see this. And of course, the monsoon season. Here we have, an upper level low here over Texas and an upslope flow here where all the shower and thunderstorm activity in the greens and whites here is occurring. Also, of course, portions of southeastern Texas, the Gulfport regions, Baja, Mexico here, and of course, Texas and Georgia where we're monitoring this area. But above all, the northwest flow has started to clear out some of the haze. The yellows here, that indicates dry sinking air that is moving into the area. Upper level water vapor channel is going to show the same kind of thing. Lots of convection here in the desert southwest with our monsoon starting, all stalled out, cold out frontal boundary here. And if we moved into, let's see if we can do this. Let's move into the national map here and see if we can get this up. At the surface, we have the shower and thunderstorm activity scattered about the west here, the Gulf, the desert southwest here into the upper Midwest. Notice there's not a lot of things going on here with pressure changes and another frontal boundary coming into the west coast. So this is not helping the forest fires here. And by the way, the showers and thunderstorms, although they're welcome, they're being accompanied by a light of lightning, and that's going to inhibit drowning out the forest fires because of the lightning strikes as well. And here is that old frontal stalled out boundary here in the south and southeast here, and convection here in Texas, and also the high building over the top here in the New England states, the Midwest, the upper Mississippi, Tennessee, Ohio River Valley area. Now, what forecasters do is we compare all levels of the water vapor channel, not just the simple water vapor, but we can concerned with the lower levels of the atmosphere as well for convection, thunderstorms, and they're showing up in the greens and whites here, and across the desert southwest into the upper Midwest as well. A lot of sinking air here, new storm system coming in to the Puget Sound here off the west coast. So, again, this shows us here in the low levels and then the mid levels also, where the water vapor channels are constant here. And again, the same kind of scenario. The only difference is there's a lot of warm moisture here coming in the mid and upper levels of the atmosphere around the jet streams and, of course, the monsoon season and the subtropical moisture here that's in place. this here looks like a disturbance, and if we move back in time, we can see this. Now, notice also an a retrograding upper level low here in the mid-level water vapor channel across Texas today. And notice on the northwest flow, some of these disturbances coming in with a little bit of haze and higher humidity here, coming in on the mid-level flow out of the northwest here across here. It's important to look at this. This is an upper level low here that we're monitoring. The National Hurricane Center is probably monitoring this as well, but it's going to probably be pushed out to sea because there's just too much northwest flow here. And the retrograding upper level low here, which is very, very visible on the mid-level water vapor channel here over Texas. So this tells meteorologists a lot of things. Okay, we've got upslope flow here, monsoon season, showers and thunderstorms, low levels, same thing. Take a look and dial this back. We can see the same kind of feature in the low levels of the atmosphere on the water vapor channel. It's very apparent. We can see it, and it shows up nicely. Now, if we get to the upper level water vapor channel, again, this is going to be an indication where we see the same kind of thing at all levels of the atmosphere to produce, the jet structure that forecasters are using in the model guidance to project what's going to happen. We can see the retrograding upper level low over Texas, the monsoon season building up too, on the east and northeast side of the upper level low retrograding here over Texas, and the monsoon season already ongoing across parts of the area that have severe fire danger and drought across the region. And of course our upper level low here spinning off into the Atlantic as well. Now, we can match this up as well with the composite radars of all the radars across the contiguous United States. And notice where the front is stalled out over the southeast, and then convection just comes in off the Gulf Coast into the southeast, and plenty of northwest flow here. Look back at New Jersey. Here's our showers and thunderstorms from yesterday that raced through New Jersey's coastline, first in Bergen County, Hudson County, Hudson River Valley area into Connecticut, the shore point areas, lots of lightning strikes, and then everything just collapsed here from Trenton down to Philadelphia, down to off the coast. We did this yesterday. Now, focus again on the monsoon and follow the Doppler here. And again, this afternoon, remember it's afternoon here in the west and southwest and upper Midwest. This is all convection here. All of this is convection in the yellows and the reds. Northwest flow here, no precipitation. Another prime example here is the shower and thunderstorm on Doppler radars showing up here between Austin and southwest of Houston and San Antonio here. A bunch of showers and thunderstorms here over Alabama. We'll get into the watch boxes in a moment. Most of the watch boxes here over the desert southwest, where we have, and the upper regions here also over South Dakota and North Dakota, where we have severe thunderstorm watch boxes and some flood watch boxes here. These are discrete because it's the monsoon season and it is ongoing right now. Greatest thing here, not only from a satellite point of view to look at, is the amount of lightning in these storms. And wow, it's monsoon season for sure. And these are the current lightning strikes all over the desert southwest. So this is going to hamper all the fires that are in this location. From Boise, from Washington, all the way into, this is a big problem. Plus the drought that's already ongoing. This is diurnal shower and thunderstorm activity normal over Mexico. That is completely normal. And of course, all the lightning strikes here is just incredible. And this is live. These are real lightning strikes. Anytime you see the circles that are ongoing, those are real. And of course, here it's calm right now on a northwest flow. Just an incredible view from, a meteorological perspective here. This is incredible to see this kind of scenario play out. In the monsoon season beginning, and it's incredible to just see this. So, from a meteorological standpoint, meteorologists, we look at areas in the water vapor channel where there's moisture trapped, jet stream structure. We can see all levels of the atmosphere by looking at the simple water vapor and also looking at between the low-level water vapor, the upper-level water vapor, and the mid-level water vapor and shortwave imagery to determine what's going to happen. What is happening and what is forecast to happen, then we look and to implement the models. So once again, there is going to be limitations in this particular channel, low, mid, upper level, or simple water vapor RGB channels that meteorologists like myself and forecasters and other meteorologists use to determine the impacts of operation. Low-level moisture return is an absence of clouds, can be seen due to the contribution of that particular channel. Cyclone structure distinguishes contributions of the different atmospheric layers of the water vapor. Warm, cold, and dry conveyor belts stand out. We've seen that on this discussion this evening. Jet structures as well. Some jet structures are easier to see in the simple water vapor channel than in the individual bands, and we've looked at that. But tonight's example doesn't really show that, so it's perfect on all levels of the atmosphere, including the simple water vapor. And secondary applications, convection initiation, which we've showed you in the whites, and gravity waves, mountain waves, standing waves that impact turbulence. So limitations of the simple water vapor channel, they cannot detect the fog and stratus. That's at nighttime and daytime water vapor channels that can do this. There's very little contribution from the lowest layers of the atmosphere in this particular red, green, blue channel of the satellite. So low clouds such as stratus and fog cannot be discerned, but there are other satellites that actually can see this. The daytime and nighttime satellites can actually do this, and we'll get into that spectrum in another broadcast. Upper cloud layers, hard to distinguish. That's true. And there is, again, the use of longer wavelength channels results in more atmospheric absorption at larger viewing angles. So as a result, cooler, brighter temperatures and more white and aqua coloring is observed in high viewing angles. So tonight's discussion is basically about the water vapor channel and why meteorologists use it and why it makes a difference. This is my very first installment on Weather Briefly. Again, Weather Briefly is an instructional video look into Meteorology 101. Some of the things that we look at, that meteorologists look at to make your forecast happen. For GardenStateWeather.com and GardenStateWeather.blogspot.com, Twitter, Facebook, and YouTube, I'm meteorologist Robert Smith. I hope you enjoy this video discussion, and we'll be back with other discussions. I think we're going to do this once a week. Maybe it's going to be on Wednesday or Thursday. It just happens to be in a quiet space tonight for me. So we're going to do Weather Briefly once a week, and I'll give you a heads up on Facebook and Twitter when the next episode is going to occur. Have a good evening, and thanks for watching.